Welcome to this video about user and kernel modes. After watching this video, you will be able to compare and contrast Windows user and kernel modes to troubleshoot issues effectively, explain how the modes communicate with each other. Let's start by understanding how a processor works in a Windows-based computer. The processor in the Windows-based computer operates in two different modes, user mode and kernel mode. Because of this duality, the processor can easily adapt its operations based on the code that is being run. In user mode, applications run in a secure environment. It prevents direct access to hardware and system components and operates with fewer privileges compared to kernel mode. Conversely, kernel mode is reserved for the operating system's core components. It allows only essential parts of the operating system to communicate directly with the hardware. Although most drivers run in kernel mode, some drivers are also designed to function in user mode. Let's discuss how these modes work. When an application is opened in user mode, Windows generates a unique process for that application. This newly created process is equipped with its own virtual address space and a distinct handle table, safeguarding against unauthorized access to the application's data. In user mode, distinct virtual address spaces ensure data integrity and application isolation. When an application crashes, it only affects that application and doesn't disturb the stability of the operating system as a whole. The virtual address space of a user mode application is purposefully limited in size, preventing important OS data from being accidentally changed or damaged by user mode programs. Let's understand when and how user mode is used through an example. Imagine you are playing your favorite video game, and this game application runs in user mode. A video game is a type of software application that needs to operate in a safe environment so it doesn't accidentally damage the vital parts of your operating system or access the hardware directly in a way that could compromise your computer's functionality. In this scenario, as the game runs in user mode, Windows ensures that your game has its personal, secure space to run smoothly without interfering with the computer's or other application's critical functions. If the game crashes or encounters an error, it only affects the game's process and not the entire system, thanks to user mode protections. In kernel mode, codes share a single virtual address space, allowing close interaction between each other and the operating system. If a kernel mode driver inaccurately modifies a virtual address, it can damage the operating system's or another driver's data. For example, when you print a document, the operating system uses kernel mode to send it to the printer, handling the complex instructions that directly control the printer's hardware. This close hardware interaction ensures your document is printed exactly as you see it on the screen, depicting how the kernel mode plays a crucial role in bridging software applications with the computer's physical hardware. A crash involving a kernel mode driver can lead to the failure of the whole operating system, underlining the critical nature of kernel mode operations. Next, let's see how user and kernel modes interact with each other. Communication between these two modes is essential for the smooth functioning of the Windows system. Since user mode operates in a more secure and isolated environment and cannot directly access the hardware, if a scenario arises where it needs to perform an action that requires hardware access, such as writing a file or printing a document, it sends a request to the OS. Then, the operating system running in kernel mode acts on behalf of the application and performs hardware-related tasks. This back-and-forth process is managed through a system of calls known as system calls, which is the operating system's way of providing controlled access to its resources, ensuring security and stability while allowing applications to perform necessary functions. In this video, you'll learn that the processor in the Windows-based computer operates in two different modes, user mode and kernel mode. User mode runs applications in a secured environment, preventing direct access to hardware and system components. Kernel mode allows the operating system and its components to directly interact with hardware. In user mode, each code gets a unique virtual address space, whereas in kernel mode, codes share a single virtual address space. Communication between user mode and kernel mode is essential for the smooth functioning of the Windows system. The operating system, running in kernel mode, acts on behalf of the application to perform hardware-related tasks through a system of calls known as system calls.